Hello guys, welcome to Video as Academic Tutorial. Thanks for watching our videos online. Please welcome subscribe. Please do press subscribe button and notification bell. That's our update on this YouTube channel. Thank you and God bless you. Amen. Now we're considering what 2022 Waec GCE Physics Practical, which is an alternative to practical. And this practical is basically on three branches of what? Of physics. The first one is mechanics, the second one is what? Optics, that deals with light, and the third one is what? Electricity. And here we are going to be considering the questions under mechanics, practical questions that are likely to be set in this 2022 Waec GCE in practical under mechanics branch. Now here we are given two retort stands, and these two retort stands here we attach thread to it, and this is a setup for that diagram. Now this is an alternative to what? To practical. It has been practicalized, and we are given what? The information obtained from the practical, the practicalized questions, and we have to make use of this information to answer the questions thereof. Now, the diagram above shows the end of a light inextensible thread, that is a thread that is not extendable, that is not elastic. Then the thread is labeled ACB, fixed at point A and what? B. The thread is fixed at point what? A and B. Simple pendulum of length L is suspended at the middle point C. Now, it is thread AB, and a simple pendulum bob, which is this one, is suspended at the middle point of the what? Of the thread AB. Now, and that point of intersection is labeled as D. So necessarily at the middle point C of the what? Of the thread, so that AC is equal to CB. This length AC is equal to length CB. Now, which is 0.5 meter. Angle DCB is equal to Q. Angle DCB is Q. Then the bulb is set into oscillation, and the time T for 20 oscillation measured and recorded. The procedure is repeated 5 more times by varying Q. The values of the angle Q's are drawn as shown in the figure. Now, the values of the what? Angle Q is given in what? In this diagram, figure 1A. Now, we are told that what? This angle Q is being varied using Q1, Q2, Q3, Q4, and Q5. And each case, we are to measure what? The time taken for the what? For each angle used. Now, the value of angle Q's are drawn as shown in figure 1 below, and the corresponding Ti, the time taken. Now, determine the value of Qi and T1. Now, don't forget that what? The Qi, that is the angle used for this word, this angle DCB, is represented in this word, in this semicircle, while the time is given in the form of this word circles. Now, so we have to make use of this figure to obtain our Qi and what? Ti. Determine the value of Q and Ti. Also determine the period. The period is the time all over 20 oscillation, time taken over 20 oscillations, and we have to what? We have to get our Qi now, get our what? T1, and as well as what? Our period for each what? Oscillations. Now, after that, we have to evaluate T square and cos Q. Calculate the origins. Plot the graph of T square against cos Q, starting both axes from the what? Or from the origin. Now, let's go into the what? Into the question itself. Now, solution. Let's start with our table first. How do I get our reading? The first entry here is to first get your what? Table first. The first thing is the what? The serial number. Serial number 1, 2, 3, 4, 5, then 6. Because we're having what? Up to Q6 here. So the first entry here should be your what? Should be your Q. The second entry here is your T. The Ti, the Qi, the Ti. And the Q is in degree. While this one is in seconds. And this T is in seconds. And the next one is what? Is the period. The period is given as T equal to what? T is equal to Ti all over 20 oscillations. So then the next one is cos what? Is to find the t square, then the cos q, t square, then we have what? The cos q, because we are asked to evaluate what? Cos q and t square. So these are the what? This is what should be what? Obtained from the table. Now the first thing is to what? Now we are given what? The figure 1 to represent the what? The qi. Now the first thing is to take your what? Your protractor. If it is inside your exam, they will draw the diagram for you on the exam paper. You have to take along your mathematical sets when you are going for physics practical. The mathematical set is very, very important. You need a protractor, a ruler, measuring ruler. Usually bring along 30 centimeter ruler along, so as to be to be able to cover for excesses. Now, here I have my protractor here. The first thing is to determine the Q1. Now, look at this. All this point meets this point. Now, look at this angle meet at this point. And we have to put your protractor on that point to measure your angle Q1. So, look at this. What I'm going to do here is to place the protractor on this now. So, you can see the protractor on this. Make sure that this is the center, and this one lies on a straight line with this. That's how you use your protractor. So you can see the middle point, and you hold this now to measure your what? Your Q1 now. Your Q1 here you can see is approximately what? This is 40 degree. You can see the extended line is 40 degree. So this one is 40.00 degree. So the degrees are already put on this side. That is Q1. The Q2 is 50. You can see is 50. You have 50.00. Now look at this. You read from here. This is 0, 10, 20, 30, 40. So this is 40. This is 50. This is what? 60. Approximately 60. You have to ensure that this is in the circle and they are straight to this. So you will not get correct answer. This is how you can see it's pointing towards this. So this is 60. This is 70. We have 70 degree. Okay, let's put it back so as to see it very well. So put it at the center here. Just trying to show you how to come about this one. So we have what? So we have what? The 40. We have the 40. Let's take note of this. This one must be in this. And they must be, because this is 40, 50, 60. Third one, which is Q3, is what? 60. 60.00. 60.00. We have 60.00. So 60.00. We have what? We have this one's going to be what? 70. So that is 70.00. We have what? This one is going to be what? 70, this one is 70, this one is 70. Don't forget this one must not miss. Ensure that your protractor does not shake. 70, this is 70 now. This is the middle between 70 and what? 80. This is going to be 75. So the Q what? Q5 here is 75. Q5 is 75.00. And last one here is 80. You can trace this, you can see this 80. So you have 80.00. That is that, as simple as that. Alternative to practical are easy to carry out. All you just need to do is to make sure that you have your apparatus, your instrument, your measuring instrument with you, and you measure accurately. And also ensure that you avoid any of these parameters not using the reading. So we have successfully obtain our Q1, Q2, Q3, Q4, Q5, and Q6. So that's that about that. It's very, very simple, as simple as that. So now the next thing is to get our T for each angle. And don't forget, everything has been given to us using the figure. The figure what? The figure 1A is for the what? For the angle. And this figure here, which is what? We call it figure 1B. Figure 1B is used to represent the time. Look at this one, you can even see the representative with circle, meaning that this is a stopwatch. Now, this is a stopwatch, and you can see that we have from here to here is 5 seconds, 10 seconds, 15 seconds, 20 seconds, 25 seconds. And within the what? Look at this, within this what? 0 and this point, within this and this, it means that there are 5 lines. 1, 2, 3, 4, 5. And within these 5 lines, there's another what? 5 lines between this and this. So you have to be conscious of the what? How they calibrate what we are given to you. What kind of scale they use for this what? For this circle. Now, the next thing you are going to see is that, okay, this one is 5, this is 10, this is 15, this is 20, this is 25. Definitely, for me to get to this place, but I'm supposed to be what? 30. So this is because the difference is 5, 5, 5. This is 5, 10, 15, 20, 30, 25, 30. So meaning that this one will be what? This one will be what? This one is 25, this one is 26, 27, 28, 29, then 30. Now, meaning that it is what? This is 26, 27, 28, 29, this is 29. But look at this one is not actually pointing to this place, it's pointing to this line in between, this black line. So meaning that what? Now, what does that black line represent? What does that each black line represent? You know, between here and here is 1. This is 29, this is 30. Meaning that what? We have 5 lines between this and this. 1, 2, 3, 4. This is 4 black lines with this one making 5. So 5 divided by 1. Because the difference between this is 29 and this is 30. This line is 29. This line is what? 30. So and we have 5 lines between it. So we now say 1. The difference between 30 and 29 is 1. 1 divided by the 5 lines in between. So 1 divided by what? 5 lines. So as to know your scale, 1 divided by 5 lines will give you 0.2. Meaning that every black line that you see here is 0.2. So if this one is touching, this arrow is touching the first black line here, it means this one is going to be 29 plus 0.2, which is 29.2. So meaning that this one is 29.20. Please follow me. Now, we know that this is 29, and there are 5 lines in between this 29 and 30. So 1 divided by 5 will give you 0.2. So meaning that each black line is 0.2. 0.2 plus 29 will give you 29.2. We're not going to get that one. So now moving to the next one, which is the T2. This is the T2. Now look at this is what? 25, 26, 27. Now this is 27 now. We thought that I told you that what? Each line is 0.2, each black line is 0.2. So 0. This is 25, 26, 27, 27.2, 27.4. This is 7.40. 27.40. So now that's how about that. The next one is what? The T3. What is the T3 all about? Now the T3 is what? Look at this. This is 25. This is exactly 25. But look at this. The black line is the first black line is 0.2, that's 25.2. So this will be 25.4. So this one is 25.40. So we move from that place to this place. Now look at this now. This one is not no longer 25 now. This is 20, 21, 22. This is 22, 22.2, 22.4, 22.60. So this is 22.60 for the fourth one. For the fifth one, which is T5, look at this one is what? This one is 20. This one is 21. This is 21.2 because the black one is 0.2. So 21 plus 0.2, that's 21.2. 21.20. And the last one, which is this, is what? This is 15, 16, 17, 18, 19, 19.2, 19.4. 19.40. So we have successfully calculated what? We've obtained what? The angle and the time for this what? For this experiment. Now let's do the evaluation because we have to evaluate the period and what? The t squared. So now let me put this one down now and let's evaluate the calculator here. Now take out your calculator and now begin to what? To evaluate. Now this is T1. T1 divided by 20, that's 29.20 divided by what? 20 observation. We have this place is 1.46. 1.46. 29.20 divided by 20 is 1.46. Now 20 what? 27.40 divided by 20. 27.40 divided by 20. 1.37. So 25.40 divided by 20. 1.27. 22.6 divided by 20. 1.13. 21.20 divided by 20. That is 1.06. Then 19.40 divided by what? 19.40 divided by 20. 0.97. So that's that about that one now. Now the next thing is to carry out the t square. So 1.46, as you have carried the t square, so save your time the other time. It's going to be what? 3 decimal place. Now let's leave it 3 decimal place. The square is going to be what? 2.131. 3 decimal place here. This one is 1.37 squared. 1.876 to 3 decimal place. 1.27 squared. 1.612. 1.13 squared. 1.276. 1.06 squared. 1.123. 0.97 squared. 0.97 squared. 0.97 squared is what? 0.940. So that's that about what? About that 0.940. So with that now we can find the cos of this angle. It is now ensure that your angle here, everything here is in degree so as not to avoid. And look at this. This is cos. Now the cos of Q here is cos 40. So what's cos 40 now? The four decimal is 0.7660. Cos 50. Cos 50. Cos 50. 0.6427. Cos 60. 0.5000. Cos 70. 0.3420. Cos 70. Cos 75. 0.2588. Cos 80. Cos 80. 0.17316. So that's that about that. Now successfully what? Calculate all the needed what? Values on our table. So with that now, we can easily move to plotting of our graph without wasting much of our time. So now we have to what? What are we to do here? After getting our table of values, what are the things we need to do? Tablet already have done that. Plot a graph of t squared against what? The graph of t squared. Now we have to plot the graph of t squared, and I'm going to write it here. Graph of t squared. Please follow me because I'm going to add my graph now. Graph of t squared against cos q. So now I'm trying to summarize my table of value for easier for easy recognitions and for me to be able to plot it. Now, look at this one is what? You have to plot the graph of t squared against cos q. Now, graph of t squared. So I'm having 6 value 1, 2, 3, 4, 5. Now 1, 2, 3, 4, 5, 6. Now the first value here is what? Now the highest value here, you have to first approximate your value, the one that you can plot on the graph. First thing now is what? Look at the highest value, which is 2.1. Highest value is 2.1, and this one is going to be on the vertical axis. Now if it's going to be on vertical axis, and I'm having like almost what? 12. I'm having almost like 12 2 centimeter boxes. I'm having that big boxes, that which is 2 centimeter. I'm having 12 on the vertical on my graph, and I'm having 10 2 centimeter boxes on my horizontal. So if I'm having 2 here, so I can easily use what? 0.1. Okay, if I use 0.1, will I be able to get to 2? I don't think so. If I use 0.1, I will not be able to get to 2 because 0.1 times 2 will only give me what? 1.2. So that's why I'm going to use what? Is 0.2 because 0.2 times 10 boxes will give me what? About 2 exactly. And I'm going to 2.1. So I'm having 12 to 7 boxes. So it's better I approximate this one to 1 decimal place because I'm going to what? I'm going to be what? Having odd number. So if I want to plot this one now, I'll present this one to 1 decimal place to have what? For instance, next time we're having 2.131 now, I'm going to have 2.1 here for my plotted value. So this one is going to be 2.1. The next one will be what? 1.9. The next one will be 1.9. 1.9 because this one is approximated to this one, 1.9. So it's going to be 1.6. 1.6. The next one is going to be what? 1.3. Because that cell can be approximated to what? 2. This one, you cannot approximate this one, so you leave it. This one is going to be 1.1. 1.1. And the last one here is 0.9. 0.9. So that's that for the what? For the vertical axis. For the horizontal axis now, look at this. The highest value for the horizontal axis here is what? 0.7. 0.7. Now, if this is the horizontal axis now, I can easily what? Choose. Okay, if I choose 0.1, 0.1 will be what? Be too much. If I choose 0.05, 0.05 times what? 0.05 times 10. It's given 0.5, it's not up to this. So if I choose what? Let me choose 0.02. 0.02 times 10. I will be able to get to what? 0.02 is even more what? Lesser. So let's go for 0.5. 0.5 times 10. It's going to be 5. Okay, which one should we go for now? Let's go for 0.01. 0.01 times 10. That will give exactly 1. So now let's go for 0.1 times what? 0.1 times 10. That will be exactly 1. So 0.1. I'm choosing 0.1 here. 0.1 to be plotted here. 0.1. This one I'm going for 0.1 because I have 10 horizontal boxes on the horizontal. You have 10 2 centimeter boxes on the horizontal axis. So 10 times 0.1. It will give me what? It will give me 1. And the highest number here is what? 0.7. 0.7. So it's advisable we go for what? 0.1. So based on that now, I can easily approximate this one to 2 decimal places. So it will be 0.77. So it will be 0.07. So what? So apparently I want to 2 decimal places now. So what? 0.77. This one will be what? 0.64. This one will be what? 0.50. Because there is nothing here. This one will be 0.34. 0.34. This one will be what? 0.26. 0.26, and this one will be 0.17. So that's that about what? That. So now let's hang our graph as what? As we're going to plot the graph now. So after hang the what? Graph now, we have to plot the graph of what? T squared. So the first thing is to write the title of the graph. Graph of T squared. What is the unit of T squared? That is seconds what? Second square against cos q. That's the graph. Kind of the graph. The cos q does not have what? Units. So the graph of T squared against what? Cos q. So that's the first thing. Now the next thing is to write the scale. So now we agree that we are going to use what? We are going to use 2 what? 2 centimeters represent 0.2 seconds on the T square axis, because the highest value that we have here is 2.1. So don't forget about that. So 2 centimeters represents 0.2 seconds, and the next one is what? 2 centimeters represents 0.10 units. It has no unit, so that's why I put units on cos q axis. So now let's draw it out. So you can as well leave a space here, because the highest value here is what? 7.7. So I can actually leave a space here to avoid what. So I will draw. I want to use black so I can see it clearly. So now let's see whether this one will get 2.1, because I have to be careful that we have 2.1. You have 2 sides left behind now. I have to adjust the video so that it can cover this video here. Also, we are going to 2.1. Don't forget, we are going to 2.1. We'll be able to have something. So let me adjust the camera. I've adjusted the camera. Now let's try and extend this. I have my reason for adjusting it, because we have 12 centimeter box on this side, so we have to do what? You have to prepare for possibility that these ones cannot contain that. Yeah, so that's why I have to extend it. Look at this. You get what I'm trying to say here now. We start from here. This is 0.2. So if you start from 0.2, 0.4, 0.8, 1, 1.2, 1.4, 1.6, 1.8. Okay, we still have more than enough. So now let's just go for 0.2 here from here. Here we have 0.2, 0.4, 0.6, 1.0, 1.2, 1.4, 1.6, 1.8, 0.2, 0.4, 0.6, 1.0, 1.2, 1.4, 1.6, 1.8, 2.0, then 2.1, 2.2. Then we can still even adjust it up. We want to, but because of our time, let's just maintain this size. So now you can see that on 0.2, 0.4, 0.6, 0.0. Okay, we have jumped a number here, you can see. jump a number here. Jump a number. This is 0.2, 0.4, 0.6, 0.8, 1.0, 1.2, 1.4, 1.6, 1.8, 2.0, then 2 point what? 2.2. So as I adjusted it, 0.2, 0.4, 0.6, 0.8, 1.2, 1.0, 1.2, 1.4, 1.6, 1.8, 2.0, 2.2. So here we have what? Look at this spaces. Here we have 0.1, 0.2. Let's add to this bracket 0.30, 0.40, 0.50, 0.60, 0.70, then 0.80. So don't forget this is cos Q, and this is what? T squared in second squared. So successfully what? Carry as already labeled what our hex, our vertical and what? Horizontal axis. Don't forget this is 0, 0. So that's what the solution, starting your graph from 0, or 0. That's the origin. Now from here now can start to begin to what? To insert our what? Plotted value. 2.1 now. 2.1 will be what? Look at this. We have what? 0.2. So meaning that what? Each box is 0.02. Each box of factor has will be what? 0.02, because 0.2 divided by 10 will be 0.02. Now, if this is 2.1, now how do you get 2.1? This is going to be 2.2. So this is supposed to be what? This is 2.0. This is 2.0. This is 2.02. This is 2.02, this is 2.04, this is 2.06, this is 2.08, this is 2.1. So exactly this is 2.1. So this 2.1 here against 0.77. So we try this 2.1 against 77. 2.1 against 77. Now 77, look at this is 0. This one is 0.1 divided by 10, 0.01. So this one is 0.71, 72, 73, 74, 75, 76. 77. So you chase 77 up. Chase 77 up here. And to get to the point of intersection. And to get to the point of what? Intersection. So this is intersection here. So you get to the point of intersection. So that's about that. Now the next one is 1.9. 1.9. So if this is 1.8, it's supposed to be 1.9. So this 1.9 against 0.64. 1.9 against 0.64. 0.64, C is 6. This is 6.5. 6.4 is around here. 6.4 is around here. What's here? 6.4 is around. 6.4 is around here. So we have what? 0.9 to 6.4 here. So we have this. Now the next one is 1.6 against 0.5. 1.6 is 1.7, 0.5. That is straightforward. Against 0.5. Wow. 0.5 against what? 1.6. So you can still check it once again. So that one is 1.3. This is 1.2, 1.3 will be medium. 1.3 against 0.34. This is 0.34. This is 3. This is what? This is 0.34. This is 0.34 here. Trace it up here. We have 1.3 against what? 0.34 here. So now the last one here is okay. So go to the last one. 1.1. This is 1.1 here against 0.26. This is 0.2, 0.26. This is 0.5. 0.26 is here. 0.26 against 1.1. This is our value that we're looking for is here. So now, so 1.1 against 0.26 is being located or plotted. So 0.9 now, 0.9 to 1 7, 0.1 to 1 7, 0.1 to 1 7, so 1 5, 1 6, 1 7, 1 7, 0.9 to 1 7. So that's that about the 2 units. 0.9 to 1 7, 1 7, so 1 7, 0.9. So we have to let's quickly plot the graph. So now let's quickly draw the slope and the straight line and then the slope. Find the slope. So now let me use another marker. We have one now. Now you see this one very well now. You see that. Let's say how many points this one to take. Leave one, leave two density. Okay. Takes 4 or 5 is okay. You can see it takes 5. So it takes 4 points, maybe one on the other side, another one on the other side. Very perfect graph. So now with this one now, we can easily plot the slope. I can choose one point here. I want to choose one on this side. Alright. Okay, let's plop it here. Now, we don't want a big slope, so let's plop it here. So we have the right angle triangle here. So that's that. So as well as extend this if you want to. I think it's not necessary, but if you want to avoid any form of error, just leave like that and let's pick the value. To plot this slope. So that's that point. So it's traceable to this. So now, that now is the other point here. So from here, So that's that about that. So we have the what? The t square 2 and the t square 1 here. And then we have the what? This cos square cos q1 and the cos q what? q2. So get your slope now, your slope x will be changed in t square over change in cos q. So x is equal to t square 1, 2 minus t square 1, t square 2 minus t square 1 over cos q 1 cos q2 minus cos q1. So x is equal to, what's your t2? Your t2 square, your t square 2. Look at this, is 2 points what? Is 2.02, 2.04, 2.06, 2.08. 2.08 minus 1.02, 1.04, 1.04. Don't forget that period is second square. All over cos q2. Cos q2 is 0.71, 0.07273, 0.73 minus what? Minus 0.21222324, 0.24, 0.24 bracket close. So with that now, let's take our calculator and do some what? And get the answer for our slope. We have open bracket 2.08 minus 1.40 bracket close. Okay, 1.04 bracket close divided by open bracket 0.73 minus 0.24 bracket close. We have what? 2.12 what? 2 seconds. So we have what? 2.12 seconds square, because seconds square. So that's that about that. So you have to write the precautions taken if you are to carry out the experiment in what? In laboratory. The first thing is that I avoid error due to parallax. I avoid error due to what? Parallax. That's the precautions. Precautions I would avoid error due to what? Due to parallax. When taking my reading, error due to parallax. When taking reading on protractor and stopwatch. I will avoid what? Ear jots. I would avoid ear jots so that this will oscillate, not rotate. To avoid what? Rotation, so that you can have good oscillation of the pendulum box. So that's that about the experiment, and this is the first practical that you might likely to meet under what? Under mechanics, which is usually what? This one is usually a simple pendulum, and they might ask you one question that will be that you will define what simple or pendulum. Simple pendulum is when you have a restoring force of a particular what? Material is directly proportional to the what? To the displacement. That's just the simple derivation of simple harmonic motion. When the restoring force is directly proportional to the what? To the displacement. So F will be equal to what? Kx. So in other words, similar what in a layman language is all in the what? In physical term of definition is that the movement of to and fro of the body is a movement of to and fro of the body in which the restoring force is directly what? Proportional to the displacement. So that's that about that concerning that. So another thing we can ask you to divine period, divine what? Frequency, and state the formula for calculating the period of a simple harmonic chord motion. So that's the next question you can meet under the B aspect of the chord. So we have come to the end of today's class. If you haven't subscribed, please do press subscribe button and notification bell, and so that update on this YouTube channel. Thank you and God bless.